Hello pre-calc students, today we're talking about the law of sines ambiguous case. So remember in our previous notes we learned about the law of sines that said if you had a triangle that's not a right triangle, you could still solve for missing sides and angles using this formula. Side A divided by the sine of the angle opposite A is equal to side B divided by the sine of the angle opposite side B, and that's equal to side C over the sine of the angle opposite of C. So we're going to do one example to review that, and then we'll talk about how the ambiguous case is a little bit different. So if we look at the angle measures here, we have 32 and we have 57. So this triangle is almost a 30, 60, 90. So I'm going to draw one that's just like a 30, 60, 90. And let's see, my angle A is the one that's 32. So I'll put that here. And B is 57, and if I subtract from 180 I can find angle C. So angle C is 180 minus 57 minus 32, so that would be 91. Okay, and then they also tell me that side C is 27. So it says solve each triangle for the indicated side and round each answer to the nearest tenth. So I need to find side A. So I'm going to do A over the sine of angle A. And then I have to decide if I'm going to use B or C. So if I look at the given information, I'm not given side B, but I am given side C. So I'm going to do C. 27 over sine of C, so that'd be sine of 91. All right, so now I need to get the A by itself, so I'm going to multiply both sides by sine 32. And these will cancel out, and in my calculator, I'm going to put 27 sine 32 divided by sine 91. Okay, and I need to check and make sure my calculator is in degree mode. So press mode. If you're not in degree mode, you need to highlight degree and press enter. And now I'm going to type 27 sine 32 divided by sine 91. Okay, and it says to round to the nearest tenth, so my answer is 14.3. Okay, so in the ambiguous case, I'm given two sides and an angle instead of two angles and a side. And let's talk for just a minute about why the ambiguous case exists. So remember from geometry class, now this is not in your packet of notes anywhere, so this is just a listening moment for you. In geometry class, you learned that you could prove two triangles were congruent to each other if you had three sides, if you had side angle side, if you had angle side angle, angle angle side, or hypotenuse leg. So these are all ways that you could prove two triangles are congruent because there's only one way to make a triangle with these cases. However, in the ambiguous case, and you might recognize this chart from previous notes, in the ambiguous case, you have several things that could happen. You could have no triangles, one triangle, or two triangles. Now, no triangles happens. You can see here that this side is just not long enough to meet the other sides. So if you have a side that's just not long enough, that would make no triangles. And you can see that's happening here. And it's also happening right here. This side's just not long enough to make a triangle. But the interesting case is when you can make two triangles. So that's what I'm looking at right here. Now it's only going to happen if you have an acute angle. And it's only going to happen in the special case when this side is long enough to turn and make more than one triangle. So let's see if I can show you that. So you're given this angle A, that's set. And you're given this side here, B. And you're given this side here, A. And what happens with this A is it can actually swing over to here and make another triangle. So you can make two triangles with the same given information, with this angle, with this side, and with this side. And so I wanted to show you what those two triangles would look like. The first triangle, it happens, when your A is over here. So here's the angle that you're given. Down here we're given this angle. And here's one of the sides we're given. Call that B. And then over here is another side that we're given, A. Now, given the same information, this angle has not changed down here. This side has not changed in length. And this side has not changed in length. And given that same information, you can make two triangles. Now, I call this one the acute triangle because all of the angles are acute. And when you solve with law of sines, that's the answer that the calculator will give you first. And then I call this triangle the obtuse triangle because it does have an obtuse angle right here. And we have to do some extra steps to find this triangle. So here are some shortcuts for trying to figure out how many triangles you have. If you're given side-side angle, you're going to use the law of sines to find an angle. And if you do that and your calculator says error, that means that one of your sides was too short and there are 0 triangles. So if you get an error, 0 triangles. If there's no error and your given angle was obtuse, then you could only have one triangle. So the only way you can get 2 triangles is if they give you an acute angle. And if there's no error and your given angle is acute, then we're going to try to see if there are 2 triangles. So what we're going to do is find the first triangle. And if the second triangle doesn't make sense, then we will eliminate that as an answer and know that we only had one triangle. And to solve the second triangle, you take the first angle that you found with law of sines and you subtract it from 180, and that's going to give you the angle in the second triangle. And I know that that's kind of hard to picture in your head right now, so we're going to look at an example that will show how that works. All right, on your notes, you do not have the triangles that I have. It helps me to try to sketch the case that they're describing so that I can see visually how many triangles I might have. So in case 1, it tells me angle A is 54, and I just make a habit of always putting the given angle right here in the left corner, and it tells me that side A is 62, so side A is opposite of angle A, so that's 62. And then it tells me side C is 75, and I always make a habit of putting the other side that they give me right here on the left as well. So that would make that this angle C down here. So angle C is opposite of side C, angle A is opposite of side A. So this is my given information. And if I use the law of sines, I can find the missing information. So I need to use the pair that they give me. They give me A and A. So I'm going to say side A 62 over the sine of 54, that's A and A. That's going to give me side C, 75, over the sine of C. And if I cross multiply, I get, let's extend this, 62 sine C, this times this, equals this times this, 75 sine 54. And then if I divide by 62, I get that the sine of angle C is equal to 75 sine 54 divided by 62. And then you're going to do inverse sine to find that answer. So, as tempting as it is to start typing earlier in the problem, if you save all of your typing for the end, then you will not get rounding errors. So inverse sine of 75 sine 54 divided by 62. And close your parentheses there. All right, so let's type that in and see what we get. Inverse sine 75 sine 54 divided by 62. Okay, so I get 78.14 degrees because this is an angle. Okay, so C equals 78.14 0.14 degrees. Okay, and now if I subtract from 180, I should be able to find angle B. So B is 180 minus 54 minus 78.14. So let's find angle B. 180 minus 54 minus 78.14 for 47.86. Okay. All right, and now the other piece of missing information is side B. So to find B, I'm going to do B over the sine of 47.86 is equal to, and it's best to use your original information, so I'm going to do 62 over sine 54. And I'm going to multiply both sides by the sine of 47.86, so I'm going to get B is equal to 62 times the sine of 47.86. And that's divided by sine of 54. Okay, and let's type that in and see what we get. 62 sine 47.86 divided by sine 54. And we have 56.83. So that's this side right here. Okay. Over here in case 2, we're going to see if we can make another triangle. Now the way this triangle would happen is if I took this side over here, and if it could swing back over here to make another triangle. Now notice when that happens, this angle gets really small, and this side gets really small, and my C is now over here. But what didn't change is the values of the angles and sides that were given. So that this here is still 54 degrees. And over here I still have 75. And over here I still have 62. So what did change is this angle C over here. The first angle that you solved for, which was angle C, it was 78.14. When it swings over here, it becomes an angle that forms a linear pair with the original, and so you subtract from 180 to find that. So your new angle C is 180 minus 78.14. So notice it's going to become an obtuse angle, and it's going to become 101.86. Okay, so I have that one, 101.86. And now I need to find my new B. Well, remember also that all of the angles in the triangle have to add up to 180. So new B is going to be 180 minus 101.86 and minus 54. So it should be pretty small. Let's see what that gives us. 180 minus 101.86 minus 54. So we get 24.14. Okay, and then the only thing that's missing is side B. So to find side B, we're going to do law of sines. It's going to be B over sine of our new angle B, so sine of 24.14, is equal to, let's go back to original information, A and A. So that would be 62 over the sine of 54. Okay, and we're going to multiply both sides by the sine of 24.14. So I'm going to get that B is equal to 62 times sine 24.14 divided by sine 54. Okay, 62 sine 24.14 divided by sine 54. Okay, and then side B is 31.34. All right, so then in our chart, we need to put all of our information. So here we found a side B of 56.83. Angle B was 47.86 degrees, and angle C was 78.14 degrees. In this one, we found first our new angle C was 101.86 degrees. And then we found this angle B was 24.14 degrees. And then side B was 31.34. Okay, so the space in here is kind of tight, and I'm noticing now that it says to round sides to the tenths and angles to the nearest degree, so I think I'll try to do that from now on. But if you make any rounding along the way, if you decide not to put everything into your calculator at once, make sure that you give a couple decimal places so that you don't have a rounding error in the end. Also, I'm going to skip around a little bit so that I can show you at least one example when there's two, one example when there's one triangle, and one when there's no triangles. And then after I show you one of each of those, then you can decide if you want to go back and watch the second video that shows a few more examples. So the next problem that I'm going to do is problem 3 in your notes. So in problem 3, we're given an angle and two sides again, so it's still side-side angle. And I drew a picture where my angle A is about 88 degrees, so it has to be a little bit less than 90. And then opposite of that is 75. And then my side C, notice I moved my angles around so that my angle A is in the left, bottom left, and my angle C is in the bottom right, which puts the sides still here and here. Notice the bottom part is dashed because that's not given. I know my angle is 88, so it's set where it has to be, but it's not set how long that one's going to be. Okay, so I'm going to solve with law of sines, and I'm given A and A, so I'm going to start with that. 75 over sine 88. And then I need to find C because that's opposite of what else I'm given. So that would be 50 over sine of C. Cross multiply, I get 75 sine C equals 50 sine 88. And divide by 75, sine of C is going to be 50 sine 88 divided by 75, and then do inverse sine to find angle C. So in your calculator, you're going to type C is equal to inverse sine of 50 sine 88 divided by 75, and let's see, we need parentheses here, and then we need parentheses here. So let's type that in and see what we get. Remember to close your parentheses here. Okay, so we get angle C is 41.77, and I'm remembering now that the directions said to round to angles to the nearest integer, so I'm going to call that 42 degrees. So I get angle C is 42 degrees. Oops. And that goes right here. And then I'm going to subtract 42 and 88 from 180 to find angle B. So angle B is 180 minus 42 minus 88, which is going to be 50 degrees. So here's 50 degrees. And now I need to solve for side B. So I'm going to have, let's see, side B over sine 50, and go back to your original information, which will be A and A. So 75 over sine 88. Multiply both sides by sine 50, and I'm going to get B is equal to 75 times sine 50. And divided by sine 88. Okay, so let's type that in, see what we get. 75 sine 50, close your parentheses, divided by sine 88. And I get 57, and it said to round it to the tenths place, so 57.5. And that would go down here. Okay, so I'm going to put in 57.5, and that my angle B is 50 degrees. Okay, so let's go to case 2 now. In case 2, I still have 88 degrees, 50, and 75. And to find my angle, I need to go to the first angle that I found, which was 42 degrees, and subtract that from 180, so that in case 2, my new angle C is 180 minus 42, which is 138 degrees. So I put 138 degrees in here, and all of a sudden I notice that 138 plus 88 is already well over 180. So this case does not make sense. So there is no case 2. And there's just one triangle. All right, and let's skip ahead again to see one more case. Let's look at number 6. Next page. All right, in problem 6, we are given angle A 96 degrees. And we're given side A is 15. And we're given that side C is 18. So I drew a picture of that right here, and I'm going to set up law of sines. So here's my given information, A and A. I have C, but I need angle C, so I'm going to set up law of sines with those. So I have 15 over sine 96 equals 18 over sine C. And cross multiply 15 sine C equals 18 sine 96, and divide by 15, so sine C is 18 sine 96 divided by 15, and do an inverse sine. So C is equal to inverse sine 18 sine 96 divided by 15. Okay? And we'll type that in. Okay, second sine gives you the inverse sine, 18 sine 96, close parentheses, and divided by 15. Okay, and there's an error. And the reason why there's an error is because I cannot do the inverse sine of this quantity. Look what happens if I take the inverse sine out. And I go back. Let's see if I can just delete that one. Yep. So this quantity here, there's also an error, and that's just because I had an extra parentheses. Okay, this number is bigger than 1, and remember that you can only do inverse sine of a value that's between -1 and +1, and that's why it didn't work here. But what this is telling us in this case is that there is no angle that can have this sign, which means that this case cannot exist. So actually, there are 0 triangles. And the reason this happened is because even though I drew this side to reach the opposite, it's actually a little bit too short. So if this is 18 here, the 15 has to be a little bit shorter than that, and it's never going to reach the opposite side. So even though I drew a triangle, it turns out I didn't really draw it quite to scale, and this 15 was too short to reach the other side. And when I found an error here, I realized that there were no triangles. So let's just look at this word problem here. In this word problem, a real estate agent has taken a trade class and she's considering buying a piece of property and is waiting for the surveyor's report before closing the deal. So the surveyor submits this drawing, and the agent actually is going to reject the sale, and we're trying to figure out why. So my suspicion is that maybe this property does not represent a triangle, meaning that it would be impossible to have a triangle with these dimensions. So the way we can check this is with the law of sines. We can put letters here, so let's call this A, and let's call this B and C. So I can do A over sine A, so that would be 370 over sine 71 equals C over sine C, 400 over sine C, and cross multiply. So I get 370 sine C equals 400 sine 71. And divide by 370, so sine C is 400 sine 71 divided by 370, and then inverse sine. So what I'm hoping is going to happen is that I'll get an error which would tell me that I couldn't have this triangle couldn't exist, and that means that the surveyor made a mistake. Okay, so let's type that in and see if our suspicions come true. Remember to close your parentheses. Okay, and the error there tells us that it is impossible to have a triangle with these dimensions. So it says explain why the agent will reject the sale. Let's write that this gave us an error, and the agent will reject the sale because the surveyor made a mistake. There are no triangles with these dimensions. Okay, so I gave you an example where you had 2 triangles, one where you had 1 triangle, and one where you had 0 triangles. And I'm going to make you a second video that shows the problems that we skipped over. But if you feel ready to try your 2 problems that you need to do on your own, feel free to try those now. And then if you need to, you can go back and finish up the other problems as notes.